Hi everyone, Ernie Tech here, and I want to do something fun today, and that is to do a little programming in REXX, which is Music SP's interpreted language. It's the language you can use on the go, as they say. And now, I'm not a I'm not the world's greatest programmer, but I know enough to be conversive. So, as with everything, I give you the caveat that I'm learning as I go here, and there's so many things to know. And you guys have been fantastic about in the comments teaching me things that obviously I don't know because a lot of you guys are professionals, and that's great. All right, so what I want to do is I want to write a REXX program, and it's Music SP's interpreted system. It works in Sim 390. It works here. So it's compatible with the IBM OS 390 TSO version of REXX. So I'll put a link down here to this. The only difference is, and there's a little bit of a difference, the difference is that Music IO needed to have a couple of modules, a couple of functions built so that REXX could write to its operating system versus the expected MVS, at least in the IBM sense. So the people at McGill wrote a couple of little functions. One of them is called Music or Muse IO, and all Muse IO is a way in which for REXX and I think other operating or other programming languages, if you include it as a module, to write to the Music IO operating system or the Music SPIO. So that's the difference. No big deal. All right. Right now I'm logged in as $000. The usual rules apply, as they say. Let's do a quick dir. There I am. And number 9 here is addnums.rex. And what I did was wrote a program that adds two numbers and it does two things with these two numbers. One of which it prints it to the screen, the standard IO. And it also prints it to a text file, which then I could print using the Music SP printbat facility, which I talked about in the previous video. So let's jump in there and do that. Let's type in edit, and then the name of the file, number 9 there is addnums.rex. Again, or you don't have to call it rex. It doesn't have to be .rex. It can be anything, but .rex, obviously, so you know what it is. Well, there it is right there. Let's take a look at it. Let's go line by line without getting completely flummoxed with everything. Let's just start in there. The inc, all that says is include REXX. You're going to ask it to use the REXX interpreter. Now, the REXX interpreter is part of the system library, so it's available to anyone who has permission to use it. So in my case, I have permission. I haven't tried it as other people. There's only one other person in this, and that's the guest. I haven't tried it, but if a new user was established and those kinds of rights were given, they too could write REXX programs and run them. They may be limited as far as what they can actually access or do, so they don't blow things up. But in this case here, I'm the admin, so I can do as I please, more or less. All right, same thing over here. It just says this is what this does. It gives you, the little comments section, the delimiters for that. In REXX, you use the phrase or the word say when you want to ask a question. And when you want to get information or solicit information from the keyboard, you use the pull command. So you can sort of relate that to other programming languages like Fortran or Basic or what have you. Down here, I'm going to create on the fly a variable called sum. Now, one nice thing is that REXX in this case here is automatically assigning the variable type, so I don't have to. In this case here, it's merely integers. Right there, the plus sign will be the function or the operation I'm going to use. I'm going to pull those two numbers from me in the keyboard, assign the result to sum, going to say to me on the screen, hey, the results of this little addition here is whatever the case may be. That goes to the screen. We could stop right there. I mean, we could have like the smallest program in the world this side of Hello World. But we want to go a little bit further. We want to actually create a file, and from that file, we want to dump the records, the results, and the information about how we arrived at the results into that text file, and then we want to be able to use the printbat command to print it to the virtual system printer. As I explained in a previous video, the printbat command solves a couple of problems with printing of things getting caught in the output queue that the guys at McGill University knew was kind of a problem. So that was nice. Okay, how do we do that? Well, the first thing we have to do is we have to assign a file name, and then we'll just FN is just what I called it, file name. This is important because it has to be uppercase. Even though the address, even though the file itself can be referred to in lowercase, the operating system expects this to be all uppercase. This here, the USR is this. So user, this is the space holder or the placeholder for whoever you are logged in as. So asterisk USR means me. Add result is the name, just the name of the file. It could be addresult.doctxt, addresult.me, addresult.nothing. Arbitrary. I just created that name right there. So what we're going to do then is we're going to take these three variables, the two we got when we were entering what numbers we wanted to add, and then the resulting variable, and we're going to line them up in the queue, which is a temporary area of Music SP waiting for something to happen with them. So I have three things, three numbers sitting in queues line by line. I could have lined them up on a row using any kind of thing if I wanted to, but in this case here, I'm just going to put them all in a row here by their lonesome. This is that function that the guys at McGill wrote, Muse.io. Muse.io is what you use to write the results to the music operating system, so the Music SP operating system, so you can use its file names rather than IBM and MVS, because that would not work. Okay, Muse.io write the name of the file, all of the records, takes care of that. This is important because in the mainframe world, you have return codes. And return codes tell you whether or not things went pear-shaped, as my friends on the other side of the pond would say, and why they went pear-shaped. So if an error occurred, you're going to have a result code, and that result code or return code is going to mean something. It could mean that the file is already opened by by something else. It could be your rights don't give you enough rights to do to write it. So that's a return code. If all goes well, we'll have no problem. The return code will be 0. It won't even bother mentioning anything. It'll go right next to the next do loop, and then it'll write everything out to the text file that we can then print. There it is. That's the program in REXX interpreted as she is. And all we have to do is just make sure that we are in the command prompt and type in save. And it saved it or overwrote it. Nothing happened, but it does anyway. F3 knocks that out. Now, there it is right there, number 9, addnums.rex. We just wrote that or just showed you it. All I have to do, I don't even have to say submit or call or anything. I just type in the name of the file. So I type in addnums.rex. And I'm doing it in lowercase, even though internally Music or Muse.io, no, not Muse.io, but the assignment of the name for the file has to be in uppercase. Yeah, those are the things that will make you crazy too. You'll be writing a program and you'll be smooth and groove, everything's going along, and it just won't work. You're just getting problems. What it will say is, I can't find the file that you want me to write to, or I can't write that file. Here's the return code. It's return code 5 or something. And I can't, well, why can't you do that? It looks, well, because that particular function has to be in uppercase. So these are the little things that can make you a little cray, as they say. All right, addnums.rex. I press that, and it says, all right, what do you want? Give me a number. Any number will do. Let's say 4. What's the second number? Let's say 5. Well, 4 plus 5 equals 9. No kidding. But notice at the end it says end go. It's returning no error code, no result code. Everything went through just fine. So if I do a dir, I have a new file, number 10, add result. And add result is the file that I specified to be created at the end of that REXX interpreted program, and it did its job. If I want to see what's in there, type in view, add result, and there it is. Those are the 3 variables, the 2 that I entered in, and then the result. No big deal, really simple, no magic yet, right? All right, so I press F3, pop out of here, get back to the go prompt. Printbat is the name of the file which can then print this to the virtual printer, the printout.txt inside of the directory off of your C drive where you keep music sp-tk. So if I say printbat and type in add result, which is the name of the file that I want to print, if all goes well, which it did, it says right there, all right, in progress for a fraction of a second, 6 records submitted to music. It routed them to the system printer. The file address, the file add result, which is the name of the file I created, sent to printer device by music sp batch job. And the printer device, which is in the configuration file, is the system device. So I go over here to printout.txt, double click on that. And it says something happened, right? Yep, it did. There it is right there. Look at that. So I've done this before, obviously. I haven't cleared it out. But the latest thing that got printed out was the results of 4, 5, and 9. End of job, user me, the time, the date, how long it took. Service units in case I wanted to charge my credit card, I guess. 3 cards read, which refers back to the old IBM punch card days, each one of these things having been a card. And at the end of the day, there were 6 lines printed, and there it is. That's it. So you've now gone full circle. You've actually created a file. You've written a program. We've written a program. We've used the REXX interpreter to interpret the program. We've printed the output. We've asked questions. So we got input from the user. We've created a result. We've put it on the screen, and we sent it to a text file. And then we went and we printed the text file to the standard system printer, which was what was defined in the SIM390 configuration. So we've really made a lot of progress here with understanding how Music SP works and the philosophy behind it. And it's also applicable, at least in terms of the concepts, to moving on to the other operating systems, primarily, of course, MVS, which is far more complicated. So there you have it. And by the way, I, again, cannot say enough good things about the comments. Thank you very much. Many of you guys are professionals. You've done this for your job, for your careers, and you're giving me great information. And I'll be honest, some of it I don't really grasp because I didn't do this for a living. And so I'm learning a lot, and perhaps one day I'll figure out a way to put that all into some kind of a organized file or something we can all enjoy and read them. But anyhow, there we are. So I hope you enjoyed this one. Kind of brings us full circle, gave us the full experience from beginning to output. All right, please subscribe if you haven't done so, and I will talk to you soon. All righty, bye for now.